Good morning, students. This is Mr. Ridpath, and we are starting Chapter 2. And Chapter 2 is about graphing trig functions. Now, the first thing I want to say is that most of you just want to go grab Desmos or a graphing calculator, and anytime you're asked to graph, you graph things. But graphing is not really about just getting a graph. Graphing is about the characteristics of the graph. And so many of your questions are going to be about characteristics. And that's where all the mathematics is. I already know that you can get a correct graph by using Desmos or whatnot. What I don't know is, can you get a correct graph without a graphing calculator? So use your graphing calculator to help, but you're going to have to figure things out otherwise, and you're going to have to be able to figure them out and show them mathematically on tests and your written homework. Okay? So let's get started and see how we graph. Alrighty? So what you see at the top of the page is the first quadrant from 0 to pi over 2 and the values we get for the special angles. We've seen this table a bunch. We've used it a lot, and we're going to use it all semester. And we're also going to use it to do the following, all right? We're going to use it to graph because it really gives us x, y values. What we're saying is the sine of 0 is 0. So this is the x value, and these values inside the table are the y values. And so we're going to use those. Those give us ordered pairs. So for instance, for y equals sine of x, if I wanted to graph that, I could graph these ordered pairs. Okay? And so that's the first thing that you need to realize, is that this table just gives us key ordered pairs that we can graph for the sine function. And it gives us a lot more ordered pairs as well, and I'll show you that in a moment. So I've written those 5 as ordered pairs, and now we can go ahead and graph the sine function. And so we're going to go to pi over 2. So let me mark that, pi over 2. Halfway to that is pi over 4. And then remember, pi over 4 is 45 degrees. Pi over 3 is 30 degrees. So it's 2/3 of the way. So the pi over 6 is 30 degrees. It's about 2/3 of the way there. And 1/3 past that is the pi over 3. And then, of course, this is 0. And so we can use that then to graph this function in the first quadrant. So I'm going to plot ordered pairs. So let me go ahead and do that in a different color. There's 0, 0. And then at pi over 6, we go to 1/2. So we're going to put this at 1. And so pi over 6, we're at 1/2. Pi over 4, we're at square root of 2 over 2, which is about 7/10. Okay. Pi over 3, we're at square root of 3 over 2, which is about 8/10 approximately, so right about there. And then at pi over 2, we're up at 1. And so we can see that this graph follows this pattern in the first quadrant. And essentially, as you go to the next quadrant, remember these sine values stay positive, but the cosine values then become negative. Okay? But the sine ones will stay positive. So if we go to graph our second quadrant, which is from pi over 2 to pi. All right, so pi. So halfway between there is 3 pi over 4. And then we're going to go right to here, which is 2 pi over 3, and then right to here, which is 5 pi over 6. And those values in this next quadrant are going to be symmetric. They're going to be the same positive values. And that's going to be your second quadrant graph. Then we go to the third quadrant, and the sign value in the third and fourth quadrant become negative. So we're going to graph these same y values, but we're going to go in the negative direction. And I'm just going to wrap this up really quickly. And so this becomes 3 pi over 2. And then over here is 2 pi. And if we plot those points as negatives, we're going to see that we end up with a graph that looks like that from 0 to 2 pi. Now, the sine graph is what we call periodic. And a periodic graph means, or a periodic function, as we've talked about before, means that it repeats itself. So this graph will repeat infinitely in the positive direction and in the negative direction. And so if we go from 0 to negative pi, like this portion we see right here is going to be repeated, okay? And then as we go from negative pi to negative 2 pi, or we go from 2 pi to 3 pi, this red and blue portion is going to be repeated. And if you just make those table of values and graph that out, you can do this. Now, since this sine function is periodic, one of the things we want to talk about is what is the period. One of the other things we want to talk about are the maximum and minimum values, which help us find what is called amplitude. And then we want to period, and then we also want to talk about this line right here that seems to cut the graph in half, which we call the midline, which is very important and will help us when we do shifts. And later on when we do graphing, we're going to talk about shifts, and that'll be shifts up or down or shifts left or right. And so we'll talk about those things, okay? And let me mention something else called frequency. But when the graphs get more complicated, we'll look at these values as well, okay? Now, so amplitude, period, and midline become really important as we do the graphs. So what I want you to do is I want you to take that table of values, and for cosine x, tangent x, and then take the reciprocals. The reciprocal of sine is cosecant x, of cosine is secant x, and then of tangent is cotangent x. And what I want you to do right now is I want you to take those values and I want you to draw the basic graphs for each one of these things. Just plot the points so you have plotted all of these one time yourself. All right? Very important to do that. So pause the video, try and do cosine x and tangent x, and go from there. Okay? Okay, now we're back. Have you done these? Now, there is one difference. When you did cosine, you will notice that it actually started at 0, 1, and then when it went to the pi over 2, it went like this. But then, if you were to keep going, it would look like the sine graph eventually. Just moved to the left a little bit. And that's actually a feature we'll talk about later, about how sine and cosine are related later on this semester. Okay? Tangent x, you may have ran across this issue, is that the tangent was undefined at pi over 2. And so when something is undefined, what's that mean? That's a vertical asymptote. Did you catch that on your own? That the tangent was undefined at pi over 2, and then you go to pi and 3 pi over 2, and then 2 pi, etc. It was undefined, and so those are the graphs. Now, when you did the tangent, you also notice that it probably went up, probably did this sort of thing if you graphed all the way to 2 pi. Okay? And that would have been the tangent graph, and then it repeats itself. It'll repeat itself going in all directions. Okay? Now, cosecant, secant, and cotangent are also undefined at certain values, and so they also have vertical asymptotes. Now, I want to show you something really clever with cosecant. Okay? The first thing I want to do is I just want to draw a basic sine graph. Okay? And so this is pi, this is 2 pi, this is 3 pi. Now, wherever the sine is 0, the cosecant will be undefined. So the cosecant then will have a vertical asymptote wherever the sine is 0. Okay? So wherever the sine crosses the x-axis, the cosecant is undefined. Now, at the maximum value, this is pi over 2, 1, and the reciprocal of 1 is just 1, so cosecant has the same value as sine right there, and also at every other maximum or minimum point. But then you take a reciprocal of a number between 0 and 1, all these values here, and those numbers get bigger than 1. So the reciprocal of 0.7 is 1 over 0.7, so it's 1 point something. And what happens is your cosecant graph will look like this, sort of like little tiny parabolas with asymptotes. Okay? And that's the cosecant. But notice how I can just sort of mirror reflect what's going on, and that kind of gives me the idea of cosecant. You can do the same thing on secant using cosine, since they're reciprocals. Now, cotangent is the reciprocal of tangent. So what happens on the cotangent is, again, because it's the sine is in the denominator, wherever sine is 0 has its asymptotes. So its asymptotes are on 0, pi, 2 pi, instead of the pi over 2 like tangent. And it's reversed from tangent. It kind of goes in a reverse direction based on the positive and negative values. Okay? So there you go. You have everything you need to know what the basic graphs for trigonometry look like. Now, if you haven't done it yet, you should draw each one of these all on your own. The other thing talked about in the lesson is the idea of whether a function is even, odd, or neither. Okay? So an even function, it just means it's symmetric with the y-axis. So the y-axis acts as a mirror, and it's symmetric. So which one is symmetric with the y-axis? Well, this is the cosine graph, and as you can see, it becomes a mirror reflection over the y-axis. So cosine is even, all right? Odd means symmetry with the origin. And so symmetry with the origin means things are opposite places over the origin, okay? And that is sine. So here's sine, but if I continue to draw periods to the left, you can see a sine value here and a sine value here match up, symmetry with the origin. So cosine is even, sine is odd, okay? I want you to use this and the graphs of secant, cosecant, tangent, and cotangent to determine, are they even or odd? All right? A graph will be neither, just by the way, a graph that's neither would be like, say, a parabola over here. It has some symmetry right here, but it's not symmetric with the y-axis, and it's not symmetric with the origin. So it's neither, okay? So your job is to figure that out. And finally, I want to just go to the browser and let's go to Desmos really quick. And let me show you something about graphing on Desmos. So you have to go to the functions to do the trig graphs. And so I have typed y equals sine x. Now, when I look at the x-axis, it's 0 to 5, and that's not a good axis, and it goes up to 1 here. So one of the things you really need to do is you need to get good at graph settings with trig functions. And so I want to show exactly 2 periods. So based on what I know about graph settings for sine, from negative 2 pi to 2 pi will be 2 periods, because 0 to 2 pi is 1. So I put negative 2 pi there for the x value, and then I put 2 pi for the y value. So that takes me from 2 pi to 2 pi. And then it asks me, how do I want to step it? So I am going to step it by pi over 4. Okay? So pi divided by 4. I think that's going to give it to me. No, it won't do it that way. You have to do it this way. So, oops, go back. Step. Okay, so pi, it's not letting me do the symbol pi. And it didn't take the verbal letter, so let me try. Let's see, do I have pi on my keyboard? The answer is no. For some reason, I can't access the regular keyboard. I'm using my iPad here. So I'll do it the old-fashioned way. I'll do 3.14159 and then divide it by 4. So I want my steps to be every pi over 4, okay? And then the y-axis, I'm just going to go from negative 2 to 2 because I want to see that graph a little better, okay? And so, oops, I did get a pi there. There we go. Now, as you can see, it didn't quite scale this bottom graph for me correctly. I wish it should give me a pi there. I should be able... I can do it on my computer, but I can't seem to do it on this. It won't let me scale. What would happen is this would then show up right here on my scale as 4 pi over 4, which is pi. And this would show up as pi over 2. Now, when you touch these values on Desmos, it tells you the correct value. On a graphing calculator, this can be done automatically with something called Zoom Trig. And so that'll be something I probably demonstrate in class as well, so you know how to do it on your graphing calculator. But this is a great way to see two periods of the function, from the start point over on the left all the way to the start point on the right. And you can do this for each and every trig function. Okay? All right, and then just for fun, we can do y equals, let's do cosecant x, so we can see how its vertical asymptotes are going to be right where it crosses at negative pi, 0, pi, and you can see those on the graph for cosecant. Okay, that's all I have for you today. Good luck on this lesson. Make sure you memorize and know how to graph each and every individual basic function. Oh, and just so you know, in class today, we're going to focus more on the characteristics. I talked about period and amplitude. We're going to focus on those real specifically for these functions. Okay, so make sure you come to class or watch that recording.